Hello and welcome to the Chapter 1 podcast on Section 2. Today we're going to be talking about how we classify matter. So, again, most of this is going to be a review again, so I'm not going to belabor too much of this. There are three states of matter. There's gas or vapor. It has no fixed volume or shape. There's a wide space between the particles that make up gases, and there is a small amount of attraction, but not much, due to their space separating them. We also have liquids. These have fixed volumes, but no fixed shape. So liquids tend to take the shapes of their containers, and so for the most part, their volumes do stay relatively fixed. There are some slight fluctuations as a function of temperature, but for our purposes, we're not going to worry about them at this point. Liquids do have a fair amount of attraction to each other, something we'll talk a little bit more about in later chapters. And then solids have a fixed volume and a fixed shape. They're the most rigid structures. They're held very tightly together, and there are different interactions that allow these particles to come in close proximity to each other. We also have pure substances. These are matter that has a consistent composition. Elements could be one form of a pure substance. Compounds, which are also pure substances, can be broken down into their elemental components, which makes them a little different than elements. And then mixtures are combinations of two or more substances in which each one retains its own identity. So for instance, if we have sugar and water, we can mix them together, but it's still basically water and sugar. We could basically use different chemical techniques to not chemical, but physical techniques to separate the substances again. And then in the figure below here, you see kind of a visual representation of this. So atoms, notice how molecules have atoms connected together. So this is an element. These are what we call diatomic molecules, and we'll talk more about these a little later in the course. Notice how molecules are like molecules of an element, but they're different elements that are connected together through different forms of bonding. And then we also have mixtures, so you can see that we have different substances. In this case, there's three different substances mixed together. Elements, and we're going to talk more about elements in a separate chapter, but there are 116 known elements. We represent elements with names and symbols. The symbols are abbreviations that represent the elements. Usually they consist of one or two letters. The first one is in uppercase, the second one usually is in lowercase. The names, vary depending upon the element, who discovered them, and things like that. Periodic table is basically the way we organize the elements, and we'll have a whole chapter devoted to the purpose of the organization and some of the information we can get from the table as we examine it as it is. And then in the figure on the right here it shows you some of the elemental components of the Earth's crust, and also the components of the elemental components of the body. Here are some elements that you have the name and the symbol. Some of the symbols come from the Latin names of these elements, so that's why lead is Pb instead of L and stuff like that. Compounds are basic elements that have come together and are connected via a bond. Compounds of particular substances always have the same composition. So for instance, if I take water from here or water from the other side of the world, like in China or Australia, the composition is always going to be H2O, or two hydrogens for every one oxygen. This is known as the law of constant composition. And then definite proportions in terms of their percent composition will also be the same, and the proportion in which the atoms combine together will always be constant as well. The properties of compounds are often very different from the elements from which they came from. For instance, table salt, the stuff you put on your fries and to make things taste salty, come from sodium, which is a metal, which actually explodes in water. And you also have chlorine gas, which makes up the chloride part of salt, which is actually a poisonous gas used in World War I, which you might have heard of in your world history class, known as mustard gas. So this explosive metal and this poisonous gas combine together to form a compound that you can actually ingest and not die from, as long as you're not eating too much of it, of course. But the idea here is that the compounds are vastly different than the element properties in a lot of cases. We also will have substances combined in mixtures. Um, in mixtures, these aren't compounds because the individual substances in the mixture retain their identity. So as I said earlier, we talked about sugar and water or salt and water. It's still water and salt or water and sugar. So they haven't actually chemically combined to become something different. They're just mixed together. Whenever you have a uniform composition within your mixture of substances, this is known as a homogeneous mixture. Sometimes we also call these solutions. If it's a varied mixture, then we have what we call a heterogeneous mixture. It's not the same throughout the mixture. So if you look at this picture here on the right, this sand mixture is what we call a heterogeneous mixture because the sample isn't constant throughout. Because sometimes you'll get little pebbles, sometimes you'll get little, the pieces of sand vary. Whereas in this solution of, I think it's salt water, is a homogeneous mixture. The amount of salt and water would be uniform throughout this glass, assuming it's been stirred and properly dissolved, which it has been. We can also classify matter. So this is just a little diagram to help you kind of go through and decide what kind of mixture you have, or whether it's pure or an element or a compound and things like that. And then on this last one, again, another kind of flow chart to kind of classify things as well. And that is it for now.